We create robots that are inspired by jellyfish. Jellyfish are a great model organism because they're the most energy efficient animal in the world. My lab works at the intersection of robotics, biology, and fluid dynamics. Our goal is to create bio-inspired robots so that we can send them out into the ocean to collect data for us. It's really challenging to monitor the ocean because the ocean is so vast and it's always changing. And so even though our robots currently are able to do lots of fantastic things, one of the bottlenecks is that they consume a lot of power. The idea of using these jellyfish robots with live animals is that we can expand all the different tools so that we can reach places deep in the ocean or in more remote areas that we can't currently access. The work in my lab is currently fundamental, so we're understanding how we can control the jellyfish and make them turn and maneuver. We recently discovered this really interesting mode of jellyfish swimming that no one has characterized before. It's doing this thing that I can only describe as hula hooping. Currently, my PhD students are studying the hydrodynamics of this behavior. Does this actually make the jellyfish swim faster? And how can we create a robot that mimics this behavior as well as normal jellyfish behavior? Some of the more robotic work in the lab focuses on incorporating shark skin features onto robotic flapping fish fins. Sharks naturally have these things called denticles, which are like little scales, and they interact with the flow to reduce the drag and increase the thrust and the efficiency of these underwater vehicles. It's been great having the freedom and flexibility of the Packard Fellowships. We're able to explore new areas of our lab that we don't really have the expertise in. We can do more high-risk, high-reward projects like creating these biohybrid robots with new model organisms. Ultimately, we want to learn more about our oceans so that we can track these different markers of climate change and be able to detect and prevent situations like coral bleaching. I really hope that my lab is able to create a variety of different types of robots so that we can then test them in the field.